Let's continue with reciprocal function. So we have 1 over x plus 2. So meaning that there is a condition for reciprocal function where x plus 2 cannot be 0. So if x plus 2 cannot equal to 0, so we can say that x cannot be equal to negative 2. So this x equal to negative 2 is actually the asymptote, the vertical asymptote of this function. So we can sketch dotted line on the graph, okay, which is no graph at this line. Next, you find the y-intercept. When x equal to 0, then we get fx is equal to 1 over 2y. You can substitute 0 here. So 0 plus 2 is equal to 2. Then you get 1 over 2. So you have the point 0, 1 over 2. Here is 1 over 2. Okay, so this is the point. So, how to sketch the graph? Okay, still cannot imagine how the graph looks like. So you can substitute, let's say, by 1. So if you take x is equal to 1, so when x is equal to 1, then you have f1 is 1 over 3. So it's lower down. So this, let's say this is 1, so it should be lower down. So from here you can connect these 2 points, then you will get as this. So these are the 2 points that you find, and then if you still continue substituting the values of x by, let's say, by 2, by 3, and so on, you will get this function will approach 0. Okay, so f of x will approach 0. But if you substitute some with, let's say, you take negative 1, then you have 1 over 1, so which is equal to 1. It goes up. Okay, so then you get this graph. You will do the same for another part, so this lower part. Okay, so if you notice that if substituting x with, let's say, negative 2, then we'll get no, if you substitute x with negative 1, you will get negative 1 here. So you get negative 1, sorry, when you substitute x with negative 3, then I get negative 1 is up lower down here. So if you continue substituting x with negative 4, then I get negative 1 over 2 is above this point. So if you continue all the points, then you will get this shape. So from this graph, we can say that the domain of this reciprocal function is all the real number except negative 2. Same for range. Range can be any value, any real number except this line, except y is equal to 0. So therefore, we have this. We can write as this. Domain f is equal to all the real number except negative 2. Range of f is all the real number except 0. So you can have a try on this another reciprocal function. Now let's look at example of third function. For third function, we have also a condition to consider. So for third function x, this x minus 2 should be greater or equal than 0. So from here that we know that x should be more or equal than 2. So same as before, you have to find a few points to plot into the graph. So let's say you take f2, so meaning that x is equal to 2. So when x is equal to 2, then you find f2 is equal to 0. So you get one point there which is equal to 0. So let's say this is the 2, 0. So this is the point. And then when we take x is equal to 3, then we get the f3 is equal to negative 1. So from there, you can connect the 2 points to get the graph. So here is the graph. So what about the domain and range? So from the graph, we can see that the domain of f is from 2 upwards. So from 2 to infinity. And the range of f is from negative infinity up to 0. You can have a try on the second set function on your own. Next, we have absolute value function. So let's say we take this function, fx is equal to modulus x minus 3. As usual, you have to find the x-intercept, the y-intercept. So when fx equal to 0, then we get modulus x is equal to 3. So meaning that x can be negative 3 and 3 or 3. So this is the x-intercept. So now let's find the y-intercept. We can find y-intercept when x is equal to 0. So from here you get fx is equal to negative 3. So now we have 3 points there. So which is negative 3, 0, 3, 0, and another one is 0, negative 3. So we plot these 3 points into the graph. It's a V-shaped graph. So it's like this. So from this graph, what can you say about the domain and range? So definitely there is no limit about x. So meaning that the domain is all the real number. But for the range start from negative 3 upwards. So the range of this function is from negative 3 up to infinity. So we can write as this: the domain of f is equal to all the real number, while the range of f is from negative 3 to infinity. So you can have a try on your own for the second absolute value function. Now we go for the last type of function, that is piecewise function. So this piecewise function, so you have to sketch the graph based on the domain given. So for x less than 1, so the graph is equal to fx equal to 5. For x greater or equal than 1, the function is x plus 2. So you have to sketch the graph separately, but on the same axis. Okay, so for x less than 1, so you have to sketch fx equal to 5. So let's say this is 1. For x less than 1, so this is the graph, fx equal to 5. So now let's sketch the graph for x plus 2 for x greater or equal than 1. So we find when x equal to 1, the f of x is equal to 3. So we get 3.13. And then next, when we substitute x equal to 3, then we have 5. So we have another 0.35. So we just continue, we just connect the 2 points, then we get the graph. Okay, so now, so let's look at this graph. Okay, what do you find about the domain? So is it any conditions? No, right? So x can take any values from negative infinity up to infinity. So but for f of x, the range, so the graph starts from 3 upwards. So means that the range of f should be 3 to infinity. So we write as this. So the domain of f is all the real number, and the range of f is 3 to infinity. 3 is included.